Today's lesson is about draw triangles with the given conditions. Objectives of this lesson: draw triangles when given information about their side lengths and angle measures. Well, look at these three triangles. Triangle ABC, this is also triangle ABC, triangle ABC. These three triangles are having same side measurements. You can tone the triangles so they fit exactly on each other. That means triangles with the same side lengths or the same shape and same side, no matter how they are positioned. Okay, now let's discuss about these situations. When we have unique triangle, no triangle, more than one triangle. See, in this situation, there are these two sides of this triangle are 3 feet and 4 feet. The sum of these two sides are less than the third side. So we can't form a triangle by using this data. That means the 3 feet and 4 feet wood pieces are not long enough to form a triangle. The sum of these two triangles is 7. That is less than the length of the third side. In the same case, look at this. The two sides are 3 feet and 5 feet. This is same as the third side. In this situation also we can't form the triangle. If the sum of the measures of the two shorter segments is less than or equal to the third segment, a triangle cannot be formed. Or the sum of the length of the two shortest sides must be greater than the length of the third side in order to form a triangle. Well, a unique triangle has no equivalent. Its dimensions or shape are like no other. If the sum of the measures of two shorter segments of a triangle is greater than the measure of the third segment, then the triangle formed is unique. Look at the second case. If the sum of the measures of two angles in a triangle are less than 180 degrees, the triangle formed is unique. That means measurement of angle A plus measurement of angle B is less than 180 degrees makes a unique triangle.
So let's take a look at this one.
Now let's watch
We've got
this
a right
video.
triangle here. So because it's a right triangle, we know that that's 90 degrees. See? So we have an angle, and then this side is 2 inches, and the hypotenuse is 5 inches. So we have an angle, a side, and a side. We call this hypotenuse leg. Because we have the measures of a hypotenuse, 5 inches, and the leg, 2 inches, of a right triangle, we know the hypotenuse is the longest side of a right triangle, and this hypotenuse is opposite the given 90-degree right angle, so we have a unique triangle. This is like angle side side, but this longer side, the hypotenuse, has to be opposite the angle given, the 90 degrees. See, so it works with a right triangle. We call it HL. We don't want to call it ASS, do we? Okay, so because we have the measures of a side, side, side in this one, 3 inches, 4 inches, 4 inches, SSS is what it's called for side, side, side. And the two shorter lengths are greater than the third length, we have a unique triangle. So whether we add 3 and 4 and get 7, it's still greater than this 4-inch one. And if we add 4 inches and 4 inches, it's still greater than the 3 inches. See? So that's a unique triangle. All right. How about this one? Because we have the measures of a side angle side 4 inches, angle 110 degrees, side 3 inches, SAS, side angle side. The combined two shorter lengths, the 4-inch and the 3-inch, are longer than this third side. We know it's a unique triangle, see? You can see that these have to be longer together than this one side, right? All right. And that 110-degree angle is helping them to prove that they are longer together, okay? Now we have one called angle side angle. It's ASA, angle side angle. And because we have the measure of an angle, a side, and an angle, and the combined known two angle measures are less than 180 degrees, we have a unique triangle. See?
That's it. Now, let's look more than one triangle cases.
All right.
Let's watch this
So,
video.
more than one triangle. If we draw a 4-inch line segment and a 45-degree angle, so here's our 4-inch line segment right here, this green one, and we draw a 45-degree angle with this dotted line right here, and it's an unknown length, okay? What we can do is we can take a compass and put the point of it right at the top. We connect the top of the 4-inch segment with the dotted line. We can set compass to 3 inches. Here we go, to 3 inches. We have a 4-inch line. We set this guy to 3 inches. We put our point right there at the top. See, right here at the top. And we draw an arc like that, okay, across the dotted line. And we keep this really still. And we make a swoop and go through the dotted line once, and then go through the dotted line a second time. If we connect this top to this point where it crossed on the dotted line, we're making a triangle that's got a 4-inch side, a 3-inch side, and a 45-degree angle. See that? Because this angle right here is 45 degrees, this angle right here. But we also made another triangle that is 4 inches with a 3-inch side with a 45-degree angle. So if we ignore that red line right here, there's a big, huge triangle that's got a 45-degree angle, a 4-inch side, and a 3-inch side. See? And if we go like this, we've got a 4-inch side, a 3-inch side, and a 45-degree angle. See that? So we ended up making 2 triangles. So sometimes they can create 2 triangles, and you can use your trusty little compass to do it. So you just connect the top of this 4-inch segment with the dotted line across here, and the 2 places where it hits are going to make these identical 4-inch, 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 3-inch, and 45-degree angle triangles, see? But they're different from each other, aren't they? Yeah. Both have sides of 4 inches and 3 inches and a 45-degree angle.
Okay. Now, let's conclude with the conditions for unique triangles.